Welcome all the participants of this small short webinar about the metaprogramming. Welcome in the VMPL software house. You can paraphrase the Darman Studio sentence. We are not only writing code, we are changing the companies because our programmers, mostly seniors, works on various companies on the German market and changes not only the project we are working on, but also changing the approach to programming. And one of the part of this change of the approach to programming I would like to share with you today. By the way, we are still hiring. We have a lot of open positions, so please visit our webpage and look for what you could be interested in. Okay, so maybe we can start. Just a moment. I need to switch to the sharing of the presentation. I hope it will be the proper window. Yeah, I think we have it. Okay, the simplicity of metaprogramming. It looks like something which is wrong in the title, because usually metaprogramming is treated as a higher level of programming. And to tell you the truth, it is. However, it is a little bit different than many people think how it looks like. So the subtitle is Clean Metacode, Oxymoron, Myth or Opportunity. Many people think that the metaprogramming is hard, and it's partially the truth. So, just a moment, I have a small problem with the presentation. Okay, I hope it is okay. How it looks, how the metaprogramming looks in C++, because I'm a C++ programmer and mostly I'm working in C++. Most of the developers think that metaprogramming is something connected with templates. Maybe because of the famous book of Alexandrescu, Modern C++ Design, where the templates was described as a good way to write meta functions, function which returns types and operates on types. However, it looks a little bit weird when you try to use it. So if you look at the template metaprogramming, what is good, what is great, is built in. You do not need any additional tools. You can just write your C++ code and do some metaprogramming stuff. It's also a nice way to show off. If you would like to show how good programmer you are, you can write some code that nobody understands, and that you can show that if you understand, you are better. It's not so great. Maybe you know the KISS paradigm, keep it short and simple. Many people think that it's keep it short, keep it simple, stupid. I dislike this stupid part. I dislike to be called stupid, so I'm using the slightly different extent of this KISS word. Keep it short and simple. But if we use templates, especially if we overuse templates, our code looks like something a little bit different. I tried to call it once when I looked in the project, which was full of this template programming. And I think the best way to describe it is keep it strange and sophisticated, manifesting years of advanced search and study. Maybe you know how it looks like, and maybe you know how it forms the abbreviation of this description. It's of course hard to use, and this is the way why we would like to show off with this programming. If it's hard to use, we are great programmers using it. It also creates hard to understand compiler errors, which is a little bit problematic, because if you make a mistake, it's very hard to find out how it is. Somebody use itching, somebody use tarot, somebody even tries to analyze this error, and I think in modern compiler it's a little bit better, but in the GCC 4.9 I lately used, it is not so good. And to tell you the truth, this metaprogramming in templates, it is not so powerful. I know that if you use Boost or Boost Fusion, you think that the power of this tool is great, but I think we can do a little bit better things in metaprogramming, and I would like to show you how we can do it, and I leave you your imagination to find out what you can do in your own projects. So, returning to the source, what is metaprogramming? When I read in Wiki, metaprogramming is a programming technique in which computer programs have the ability to treat other programs as their data. I'm reading it, I read it very carefully, and I found that in the whole definition, here you see only the first paragraph, but in the whole definition, there is no even single sentence about templates. So, do we really need templates to build a metaprogram? First thing is to think why we need the metaprogramming. And this is, I think, the point we should start. We are programming in the languages which uses the strict typization. So to use this strict typization, it's good to have a lot of short, simple classes denoting the data or ideas or concept we have in our code. So we can use simple Boolean types to denote some values, but then we drop the power of the language. We drop the power of C++ or Java when we use simple values as integers, doubles, or strings to denote names or values or prices. Of course, using simple built-in types is simple to use because we do not need to do anything else. We can just name the variable price, and we know that it denotes the price. The problem is that the operation with such values are not checked with the compiler. We can multiply different entities denoted as normal numbers. We can add them, we can even divide. And compiler do not check what is happened and do not check the logic which is behind them. So it's really easy to misuse the values. When we use strong typization, we need to define each value type. This is the problem because we need to write for every single type in the system, we need to write a class. So usually we are not doing it. However, we can use the compiler to check if we are using these values properly. And the problem is that we need to use setter and getter for such values to implement the operation. And from my point of view, it's better to have the named setter and getter. So it's not as easy as create a template which bases on such value and name it using some macros. Of course, we can do it, but it's not so good. So how we can use the simple types? Here we have some examples. For example, price per item. I know that it's looking a little bit weird, but writing a program, I would like to distinguish the types to keep the compiler checking how these types are used. So this is why I decide to have price per item as a different type than, for example, a price per liter or price per kilogram or price per package. Because then I'm sure that I will multiply it by the item count. Of course, we need also the item counts, and we need also the value, which is the result of the multiplication. As you see, this code is similar. The only difference is the name of the getter and setter method, and of course, name of the class and constructor. Looks a little bit weird, but this approach protects us against assigning the count to the value or to the price and misuse the types. Okay, I said that we can have the different, or I like to have the different setter and getter. Because then I can use the technique which is well known by the people who uses Boost Fusion. I can create a set of types, and I do not need to implement here the getter and setter. If I put the invoice element as a single class, I can just derive from price per item, items count and value, instead of using the fields, 3 different fields in this class. And then I need only to create the assignment operator, because all the getter and setters are already derived from these elements. If I need to cover one of them, for example, setting the value is currently not good to have. Of course, I can use the value interface instead of the value and implement the function which returns just a multiplication. This is, of course, your decision. This is what I would like to show here. Is just an example how we can use it and how we can have the getter and setter just derived from the original simple classes. Okay, now we can implement the operators. You see, we can allow multiplying count of items by price, or opposite, price by the item counts. And of course, we can add operator which allow to add values. And this is enough. We do not need to add prices. Adding prices is something really weird. We can add some overhead to the price or some percentage. We could I think add the items count. However, we are not sure which items there are, and we should have the special types for it. So these 3 operators forms the operation which are needed, and I really don't like to have more operation that we use in our program. Okay. Of course, we can automatize creating such function, and this is the point when the metaprogramming start to be useful. For simple cases, as I showed on the previous slide, it's easy to use even macros, because you can create the class definition combined with some names, with the name of the type, using simple C++ macro definition. If you would like to make something a little bit more complex, you can use FTL. We are using FTL in the company I'm currently working for. I found that for simple or moderate cases, it's really useful. We can even use a set script which will operate on some template written as a file and just edit some position in this file and copy it to the proper class. This is also very good because set is well known, and you can always modify the original template in normal editor and then apply set to work on it. But consider something which is a little bit more complex. Algorithms which create algorithms. This is really important and nice place when we can use metaprogramming. Readable code. If we use template metaprogramming, the most important thing is that we have a syntax which is very weird. We have a syntax which is not so easy to read and understand, and of course the error messages generated by the compiler which are completely out of possibility to read and understand if you are not familiar with it. Usually when you make a single mistake, you can have even 2-3 screens of the error message, which is really complex to understand and analyze. You can also, having metaprogramming or metaprograms, you can keep the code you add to automatically generated class. This is very important if you would like to add some methods, add some code which is not easy to create automatically, but needed, and you just need to have it inside the class. So you can make a special marks in the class and keep this part when you regenerate a new version. And of course, you can make a little bit more sophisticated solution than just operating on types. You can differentiate on some flags, generating copy constructors, generating special approach to serialize the classes and so on. And most of these things are possible in C++ templates, but the complexity of such code is horrified. So I would like to show something which is a little bit easier to understand. And I would like to present it on the example. Maybe you know the problem how to convert string to enum. It's commonly used in many programs. Sometimes it's hidden, sometimes it's not typical conversion enum to string, but we have a switch over enums, switch over strings. We have many comparison. We have a cascade comparison of strings to find out, for example, some built-in values, some built-in functions in our code. So how we can use it and how we deal with it in our projects. First, we need what we need is we need to convert from outer representation, from text, from some settings, to internal, which is usually enumerated. Of course, we can use enumerated strings, but it is not a good solution because we can have various values which are out of the possibilities our program is expecting. Where we use it, we can use it in automatic log analyzing. This is, I think, the most useful place, which is not usually done, for shame. We have it in XML parsing to find out which node we are currently in or how to analyze this node. Usually we are using here the normal string comparison, but I think converting into enum and then creating by the factory the proper value, the proper analyzer or proper parser is a better idea, or simpler even from the clean code point of view. We can parse scripts. Many of the solution need internal scripting language. So parsing this script, parsing some built-in values, some context values is the place where we use string comparison. And of course, parsing also the service input, which is not so, which is the first line of defense. We are here analyzing if the values are proper and if we have the proper input of our service. So here we have a lot of comparison to check if we have the proper structure and proper values in the structure for the service. So how we solve this problem? How is the solution? First, the simplest one is just a list of comparison. I don't like it, however, it is very often used. Here you see that we are using some strings, we are using the proper comparison. Of course, in the legacy code you can find a lot of strcmp statements which hides this code even deeper. And this approach is very nice because you can have the conversion in one single place. However, it's slow. Notice that we need to think which of the values are often used, put it in on the beginning to make some speed up of the analysis, of course, if it's needed. And we need to make a lot of optimization by ourselves and by coding. Second approach is to use an array. It's much better because we do not mix the values we are using from converting the enum to string and string to enum. We are using the same set of values, and we can extend it, I think, better than usual, because we need to, of course, extend the enum and, of course, extend this table, and everything else works fine, maybe except this value. If you forget about it, we can have a problem. We can have a problem. However, here can be just a length of this table of count of elements of this table. So this is a little bit better. However, also it's not so good for the creation. We can use the maps. You see here is some much more sophisticated solution. We have a static map, which is specially designed for converting the values. So we are sure that this map will be created and will be created only once, no matter how many times we will use this translation. And here the map is, I think, the best solution for the normal programming, because we can convert in very fast manner. You see that the typical map uses sorted values. We can use fast search in this sorted values. So the price for finding the proper values is about log n. Yeah, this is the normal coding, but how we can use it when we need a real speed, when we need a very fast conversion. For example, in bank application, which works on the stock market. In such application, even microsecond is important. I remember when I worked in my previous company, we was fighting for every nanosecond in the code, because it was obvious for all the programmer that many programs are racing for the best price stock values or stock market, and the first one wins. So it was very important to be the first. So maybe we can try to compare just a single character in this enum. The problem is we need to find which is the best to distinguish the values. So we need to find out which position of the character is important. Then we can just write a single switch by the best hit position. And for each case when character identifies the single value, we can just return the value. Look that this approach, the cost of this approach is just 1, is constant. So no matter how complex is this enum, we have the 1 comparison and we can return value. Of course, if the case set is very long or it's not so easy to find the good position or to find the character which distinguishes all the enums, we can just run once again the same algorithm using the values which are the same, which are not distinguished by the characters we found previously. So at the end, we can compare the whole string just to be sure if it's of course needed. If we do not need it, if you are sure that the input is correct, we do not need to compare the string. We can just return the value without comparison. Okay, this is what we need to do when we create such a conversion function. If we know, you see that these 4 points forms pretty nice algorithm. So we can execute this algorithm by ourselves in our brains and just type the code. But if we have a lot of enums, it will be first boring, and second, we can make some mistakes creating it. So maybe we can create it automatically. Look at this Python code. I wrote it in Python because Python is, I think, well known for most of the programmers, and I would like to show also that it doesn't matter which language we select. We can use any language for creating, for metaprogramming. And Python is nice because we can easily keep this code clean without, some language overhead. So, how we can create the conversion? First, we can find the best character, and then we build a switch over this character. How we can find the best character? Of course, we need to find how many characters we would like to scan, not to go out of the list of possible values. We can assume some best position, and then we try to create a map. I put this creating map to separate function. I have the list of values, the position over which we distinguish the character, and we just create the map, and we assume that currently it's the best map. And then as soon as we have the characters, we can check if our map is a little bit better. Here is a place I would like to change a little bit, because here you see we have something which checks if the map is better. Maybe it's good to put it into separate function, because then we can create different algorithms and different methods of creating best map. But if you look deeper, a little bit deeper, you can see that creating character function is also very simple. We create a result map. We are checking the character, and depending if we already have it in the map, we append it or create a list. Here is some kind of the things I'm using in Python. It's very easy to work with the list. It's very easy to work with the dictionaries in this language without, creating some special, creating them by special function. This syntax means that it's a list containing single value. And here you can see that we are just appending value to the list which already exists. Get minimum length is, of course, very easy function. We are just checking each string with the length we have from the first one, and if it's shorter, we return it as a minimum length. Going much deeper, we can build. We already need to build a switch on selected character. Of course, it's very easy. We can write on the output. I have here the special output which has some additional facility. I will show it a little bit later. But what is important, we are creating just a text switch converted value and embraces this the position of this character, and then the range in which we are just working with the map. And here is some trick I added, because I do not want to have the default value at the end, which is not assigned, because, as I said, I would like to be sure that the value is proper. I prefer to compare it with the whole text. Here you can see that I decided to put the last value as default. we have here it is, write case for rest. So this is it should then generate the default values when no case examples left, when we have the last one. And in the normal situation, we are just creating case for the character. And of course, we ending with ending braces, and then the switch is generated. Okay, how we write these two functions? Write case for the rest and write case for the characters. They are pretty easy. You can see for character, we are writing case, this character, and we are writing the body with the values to return. For the rest, it's much easier because we do not need even this character. We just write default, and in the next line, we are writing the case body, and case body is also very easy. This is the special facility of the output. The output allow to write a code with indentation, so we can increase ident because we would like to form this code to be easy readable, and it will be, I think, also clean to show how it works. And when we have only one value, we can just type return and this value. If we have more, what we should do, we should generate the conversion switch for these values which are not yet separated. And of course, at the end, we decrease the ident because we already leaving this part of the code. And that's it, how it works. Here you see the examples. Simple example with the names of the numbers from 1 to 10. And you can see that we have over the third value, because we are in C++, we are numberating, we have the numeration from 0, so it's 0, 1, 2. These characters distinguishes these 1, 2, 3, 4, 5, 6 values out of 10 can be returned immediately. The rest need another comparison. You see here is for the first character, 5 and 7, 9 and 10. Here is very easy, true and false. Names was bool true, bool false. We can just check the fourth value, this one, the fourth character. Here you see the simple types, also without any additional check. We are checking just one character. And here we have something for the enums, which allows us to check the database we are using for, or selector for the database driver. You can also use such easy part. Such switch can be also used for factories when we would like to distinguish for which factory methods or which type can be created, so it is not limited, this method is not limited to enum. As you see, this metacode could allow, or this metaprogram code can allow us to create a lot of code without any additional work from our side, except this short part of metacode which creates them. This code which I showed is part of my own project to build up the set of simple types also with serialization. So this is why this can be widely used in our programs. And I think this is the end. I think that you can realize that metaprogramming can be simple. It's not the problem to, fight with very complex syntax. It's not complex when we use a proper method and proper tools. And it's not complex if we think about what metaprogramming really is. and not focus only on some additional features which are found in the C++, because template programming, this metaprogramming described by Alexandrescu, it's, for tell you the truth, it's a side effect. It's a side effect which is not designed specially for metaprogramming. It was designed for some simple metacoding to create a code depending on different types in the same manner. So metaprogramming, what the metaprogramming really is. Metaprogramming is some kind of auto-reflection. We are not only thinking what the computer should do in our program, we are thinking how we are writing a code, what decision we are making to create such parts of the code. And if we find some patterns, if we find some algorithms our brain operates as a programmer, we can also program it. We can put it into the code and make the metaprogramming living. So when we understand ourselves, when we understand what we are doing as programmers, we can program metacode. So I think that's the end. Thank you very much for your attention. It was a short webinar, but I think it was nice and you learned something from us, from our experience. Thank you very much, and I'm looking forward for your question in the chat. Overhead in templates should be punished. I think dealing with this code after a year or two, it's enough punishment for the metaprogrammers. Yeah, it's the concept can look a little bit better. Yes, but if you think about how the C++ improves or how the programming languages are improving, you should think also about a lot of companies who are not developing their software from the scratch. I'm currently working in a company which has the software developed since 25 years, and some parts of the code are 25 years old. And replacing of such parts is not so easy, and even replacing the compiler is not easy, because some part of the code works on the machines where the modern compiler are simply not available. For example, HPUX, which is not up to date because it works on the factory, which do not need, the constant update of the environment. Yeah. Have you been using metaprogramming in real production environment? Yes, of course. I was using metaprogramming in this 25 years old code. We are using FTL to create classes for connection with the database. So the database model is described in XML, and from this XML we create SQL statement which create database, and also the code on the C++ side which deal with this data. So then we are sure that this meta model of data, which is in C++, is fully compatible with what we have in database. Yeah, C++ 20 is a good approach, but writing the metacode in Python, I think it's much easier, and you can keep the code clean. You can apply really all the clean codes, hints and guidelines when writing some metaprograms. Yes, of course, it can be used in Java. It can be used in any programming language. It depends only how you create this part. In this project I'm working on, in this metacode generator, simple class generator, I will use the specialized generator for code. So, for example, in this switch, I was just sending to the output parts of the statement, but in the little bit more sophisticated code, it is better to use factories which will create the specialized way of building these switch statements or even other parts of code, specialized for C++, Java, Python, and the languages you would like to use. Okay, somebody asks why the side effect, the templates are the side effects, because the template metaprogramming was not designed. It was just found as a way of using templates. Templates was not designed to write a metaprogram. They were designed to use in writing the same algorithm or the same code for different types. And the work which was done by Alexandrescu was really great, because he discovered that this can be used also for metaprogramming. And this is, I think, the most important thing that Alexandrescu did. He found that the this template part of the C++ language forms another language which can be used for very complex and sophisticated code. So it's not, it's not something against the work of Alexandrescu. I'm really, I'm, how to say it in English? I really like what he did. However, in the normal code and in production code, I'm trying to work around such complex techniques, because the most important things when you work in the teams is the team ownership of the code and common understanding of the code. And writing so sophisticated code is not so easy. What makes Python code more clean in metaprogramming than other languages except for C++? It's not a problem it's not better. I like Python because I do not need to use braces, and for presentation like here, it's much better to use Python because I can put a little bit more lines of code on the slides without decreasing the font size. So this is why I'm using it. And I'm also a big fan of the clean code in C++. Currently, I'm working in such projects which try to put clean code into C++. And of course, you can also write metaprograms in C++, the programs which creates programs. It is used in many places, and I even found the possibility in C++ to create C++ programs, compile it and into DLL, and then call the function from this DLL. I found such approach of metaprogramming in production code. Switch is one of the trickiest cases, but we may get, of course, we have, the language, the C++ is the language which evolves. However, you need to think about the code which is currently used, and in many cases, of course, this metaprogramming will not be used in the modern programs. However, I think we can find a lot of places where it can be used. Is clean. Sorry. Okay. Yeah. It's a very good. Switch is one of the trickiest cases, but we can get ternary operator fault in C++ 23. Yes, in 23. However, using metacode is not limited only to modern code. We can use it also for something which is a little bit older, like me. Yeah. Okay, so if you have a question, you can always ask me using email. Or asking our specialists in VMPL. You can just enter our webpage and apply for a good job with good environment, with the great people, and make the programming be the really real fun. So I think thank you very much for your attention, for your attendance, and I'm looking forward to meet you in real life.